I'm Anil Kumar, and in this video we will understand quotient of functions. We are working with f of x equals to x minus 1 and g of x equals to minus x squared plus 1. We need to find q of x, which is quotient of g of x and f of x. We need to state domain and range of this particular function. So let's first find what is quotient of these two functions. So we are given q of x as equal to g of x over f of x, right? So basically what we'll do is we'll write down what g of x is. G of x is minus x squared plus 1 and f of x is x minus 1. Now individually their domain is all real numbers, but when we write it as in quotient, the domain changes, right? So here what we can see here is that the denominator cannot be 0. So for the quotient function, when we are considering the domain, f of x should not be equal to 0 since it is in the denominator, and that means x is not equal to 1, right? Therefore, for the domain, what we will get here is that the domain of q of x is x belongs to real numbers where x is not equal to 1, right? I know that is the second part of this question, but it's better to start with domain and range whenever you're working with functions, right? And now let's further explore this particular function. So let's simplify the given expression, which is minus x squared plus 1 divided by x minus 1. I could factor it. Let me first write this as minus outside, x squared minus 1, and denominator is x minus 1. Now I can factor this, right? So I can write this as x plus 1 times x minus 1 divided by x minus 1, correct? As you can see, x minus 1 cancel out. We do know that x is not equal to 1 since at 1 the denominator is going to be 0, right? So we can write this function q of x as equals to minus x plus 1. That means it is a straight line with negative slope, right? Or we can just open the bracket minus x minus 1. So that is the quotient of the function g of x and f of x. Now let us try to sketch this function. This is a straight line with one restriction, and that is x is not equal to 1. At x equals to 1 we have a hole, right? And the value of this hole at x equals to 1 is going to be minus 2, right? If I write x equals to minus 1 here, I get minus 2. So this means we have a hole at x equals to 1 and y value for the hole will be minus 2. So if I substitute 1 here, I get minus 2, right? Now I've already drawn the graph for your reference here. The function f of x, as we have drawn earlier also, is a straight line x minus 1. G of x is a parabola opening downwards with vertex at 0 and 1. And now we have q of x, which is this line. So this is q of x for us, right? Which is g of x divided by f of x. Y-intercept is minus 1. Slope is minus 1, and that's the hole we are talking about, right? Whose location is 1 minus 2, correct? So that is how you can actually sketch it also. So I hope with this you understand how to get an expression for the quotient of a function, how to write its domain and range. As you can clearly see, domain is x belongs to real number not equal to 1. The range is there's no restriction except for it cannot be 1, right? Because since we have a hole at minus 2. So range is y belongs to real numbers where y is not equal to minus 2. So that's kind of important, and that is because we have a hole, right? We have a hole at 1 and minus 2. So that gives you the restriction. So that gives you the restriction. Now from examination point of view, this is a very important question. So you should understand how to write domain and range for, especially when the quotient of functions is involved, right? So as an exercise, what you can do is you can find another function, which is, you can say r of x equals to f of x over gx. and you can sketch this function, find its domain range. That would be a good exercise as practice question for you. Okay, I hope that helps. Thank you.